Class, welcome to the next segment in Lecture 23. And in this segment, we're going to take a look at a typical synoptic scale setup that you see for a Derecho event, which is, again, a very long-lived and intense windstorm which you can sort of think of as a massive and powerful squall line that travels a great distance before it finally dissipating, leaving a lot of wind damage in its wake. So that's what we're going to be focusing on here. And ideally, what you want is a nice cold front, which cold fronts typically result in stronger upward motions. And the reason why you want strong upward motions is because you want a rapid transition towards linear modes if you want a fast-moving line of storms moving across a region, leaving wind damage in its wake. So to get a fast-moving line of storms, you kind of need storms to become linear to begin with, and that's why a cold front is typically ideal because it will typically result in lots of thunderstorms going up, which all merge into a large squall line or into a large line. And then you also ideally want a nice stationary front. And the reason why you want a stationary front is this can be a source for strong directional wind shear or strong baroclinic vorticity. So this is a concept that we kind of alluded to earlier. Baroclinic vorticity is the tendency for the air to spin as a consequence of having air masses that have two different densities. So you typically have more dense, slightly denser air north of the stationary front and less dense air south of the stationary front. So at the interface between those two different air masses that have different densities, the air is going to want to spin. And this spin can be what generates a large and powerful bow echo as this line of thunderstorms tracks from west to east. So that's the role that the stationary front plays in the formation of a derecho. And that bow echo, that bow echo is a really good source of producing more focused and more intense wind damage than the rest of the line. The rest of the line is also going to be producing scattered to widespread wind damage, but right at the stationary front, that's not where you want to be in a derecho setup because that's usually where the biggest wind damage is going to be, right at that interface between less dense air and more dense air. And ideally, you want southwesterly flow, which is the reason why you want southwesterly flow is one is it kind of runs more parallel to the cold front, but the main reason why is because you want these thunderstorms to quickly crash into the stationary front. So as these storms are becoming linear, you also want them to quickly crash into the stationary front so that baroclinic vorticity can start to take place. That way you can start getting that rotation that you need to really develop an intense bow echo. And if you're trying to get like I said earlier, if you want to get a derecho set up in the plains, it's actually a little bit different. You don't want southwesterly winds, you actually want northwesterly winds, because southwesterly winds just mean that your cap is going to get reinforced, which means thunderstorms are going to struggle to go up at all. And this is more of a setup that you would typically see maybe eastern plains, Midwest, Great Lakes region, just areas farther north where the southwesterly wind won't be able to reinforce the cap as profoundly as it would over the plains. And ideally, you want a nice due west component in your 500 millibar pattern, just like with a tornado outbreak, but for a different reason. Here you want a nice wind pattern that's running parallel to the storm's motion. So if your storms are moving from west to east, then you also want a 500 millibar pattern, which also moves from west to east. And that will favor a faster moving line of storms. And if the storms are moving faster, then that increases their potential for producing straight line wind damage. So ideally for a derecho setup, you want a nice southwesterly wind at 850 millibars and a due west wind, roughly a due west wind at 500 millibars. And one of the key differences between a derecho and tornado outbreak has a nice cyclonically curved jet streak, but a derecho, you want a nice elongated straight jet streak. And the reason why is because to get a derecho, you want to have strong heating that's occurring in advance of the thunderstorms, and you want a lot of energy, a lot of buoyancy building up in the atmosphere. And the best way to accomplish that is to employ the use of an elongated straight jet streak, because in the right exit region of the jet streak, that's where you've got sinking motion, which is going to be eliminating any clouds that might be in the sky, which means this area in the right exit region of the jet streak is just going to be continually subjected to intense heating from the sun, which is going to really prime the atmosphere for an intense damaging wind event as the thunderstorms approach this region. And then as the day evolves, usually this jet streak will slowly move slowly advance down the jet stream, which means this rising motion will gradually make its way towards this region of sinking motion. So this energy down here is building up, and at some point, those thunderstorms are going to be moving in the area where this energy is all building up, and that's when those thunderstorms are really going to intensify. Once they get access to this energy that's been building up all day, that's when the thunderstorms really ramp up in intensity and where the potential for damaging winds is maximized just about. And also, to get a long-lived windstorm, you want a nice broad warm sector, which is what elongated jet streak structure will give you. Usually it'll give you a nice big area of warm, moist, and unstable air, which is ideally what you want for a long-lived thunderstorm event of some kind. So that's going to do it for this segment on the synoptic scale setup for a typical derecho event in the Great Lakes or the upper Midwest region. And in the final segment, we'll talk a little bit more about diagnosing storm mode, that is determining whether you're going to have isolated storms or linear storms. So with that, I will see you all in the final segment.